All right, we've had about 80% answer that there. It looks like we're at the beginner and mid-level area here. I'll close that out and share it with everyone.
Perfect.
Yep, it's always great when you get that level, beginner, mid-level, because you know that you're bringing some value in the training, and I'm sure you're going to get something out of today's session. I'll hide that, and then we have a quiz for you mid-level folks that have the answers here. If faced with a merge operator, what is one of the possible issues? Okay, I'll go ahead and launch that. I thought I had launched it. So if you're faced with a merge operator, what is one of the issues that you may be having? Let that go to about the 80% mark. Can you see that on your side, Grant?
Yes.
Okay, great.
It won't let me answer though.
It's interesting with the little quizzes. It takes a little bit longer to get to the 80% mark. I'll let that go a little bit here, and then we'll close it out. All right, I'll go ahead and close that out. Share it with everybody. And Grant, what is the answer?
Oh gosh, looks like almost any of them. Most of the people got it right. Well, not quite, but missing indexes is one of the possible issues. It also, and depending on what we're talking about, it could be none. There's nothing wrong with merge operators per se, but one of the indications of a set of missing indexes is a merge operator. So well done, everybody.
Well done, well done. Except for the 4% that answered SQL query emulation. We made that up just to see if we could get you. So you might want to Google it, see what you get. All right, I'll go ahead and hide those polls. And Grant, I'm going to make you presenter. I'll stay on with you until we see your screen.
Okay. Can you see me?
Let's see here. Not yet.
Somebody's asking for control. No, you can't. There it goes.
There you go.
You should be able to see me now.
Absolutely. Up and running. All you.
Okay, great. Well, thanks for coming, everybody. What we're going to talk about today, identifying and fixing performance problems using execution plans. Why am I talking to you? My name is Grant Fritchey. I'm a principal DBA at FM Global. It's an international insurance company. We're actually known as an insurance and engineering company, which is kind of a weird mix. I'm a Microsoft MVP, a past chapter president, and I've written a few books. And let's not talk about that anymore. Let's talk about what we're doing. We are here to hopefully learn how to read execution plans in a way that allows you to identify some very common performance problems. There are performance problems that will not evidence in execution plans, and there are performance problems that absolutely evidence in execution plans. And so what we're going to talk about simply is how to read them, how to identify those common problems. So what we're going to cover: why execution plans, where to get execution plans, and then we're walking away from slides because I'm not a big fan of slides. I'm not an artist. I'm a geek. And so we will go and play with code. We will play with queries, and we will talk about execution plans. Some of the stuff we're going to look at is lookups, missing indexes, bad stats, recompiles, ad hoc SQL, parameter sniffing, cursors. Oops, I think we probably won't hit cursors today. Multi-statement UDFs, query hints, and whether or not a query is sargeable. And then hopefully we will have a little bit of time at the end for some questions. Yes, that is a lot of information. We might not hit it all. I'll be honest with you. This is a practice run for a 90-minute session, so I've got a little bit more information than is possible to get out. But I guarantee the stuff we get out is going to be useful. So why are we using execution plans? Well, quite simply, an execution plan is your one, only, and best window into SQL Server internals. What is happening inside of SQL Server? how is this query being processed? What is occurring when you run this insert statement? What is occurring when you run this delete statement? How many tables are being hit and what indexes? All of this kind of information are really only available through an execution plan. So if you've got a query that's running slow, you want to know why, you could sit there and bang at it, you could read it and try to discern it, or you fire up an execution plan and you can understand what it is that's going on inside of a query. It's really your best window in. It's just one of the best ways to get that information. It's not a perfect way, and we'll talk a little bit about that, but it really is just that window into Optimizer that you won't get anywhere else. Now, where can you get execution plans? Very simply, Management Studio. That's what we're going to do a lot of today. Management Studio has got an estimated plan and an actual plan. Estimated plans are simply the initial plan as generated by the Optimizer, and an actual plan is the plan that was used by the engine. Sometimes they can be a little bit different. The main thing is that the difference between an actual and estimated is the actual will include a certain number of statistics, real statistics, whereas the estimated will only include guesses, is the best way to put it. In addition to Management Studio, you can also run queries directly against the plan cache. SysDM exec query plan is where the query plans themselves are stored. Now, you can't just run a query against that DMO, Dynamic Management Object. You also have to combine that with others, and I'll show you a little bit about that. And then finally, you can capture trace events that will get you execution plans, but I caution, and Microsoft cautions, this is extremely costly. This is a very costly trace event, so be very, very, very judicious in its use. All right? Let's play with execution plans. Like I said, I don't like slides. That's just the introduction. Get you going. We're going to start off with lookups. I'm going to select this query. It's a very simple query. We're selecting just a few columns from the sales order detail table in AdventureWorks, where the product ID is equal to 897. I'm going to take a look first at the estimated plan. Now, the idea of the estimated plan is it doesn't execute the query, it just gets you the plan. It passes the query into the Optimizer, the plan comes back, and you can begin to look at it. So, oops, I'm betting we've got a problem. Hang on. That's what you get for testing ahead of time. You got to clean up behind yourself. Let's try this again. There we go. Much better. Now, if we run this as an actual plan, I'm going to include the actual execution plan. And then if I run the query, I will get back the plan. Now, I'm still not getting the lookup that I want from this thing, so I suspect I've still got an index someplace on there. Hang on one second. No. Hang on. I hate it when the demos go wrong. It's bad when the first one goes wrong, too.
It was going all too well. You got those demo gods, Grant.
I'm used to them. One second. Let's just open up the Explorer here so we can go right into AdventureWorks and clean this up. Very sorry about this. Sales order detail, indexes. Now, why would that be causing that?
Could it be the SQL query emulation?
Yeah, it actually might be SQL
It might be that.
All those people were actually right. Let's drop this. Right. Still not getting it. Huh. Okay, well, let's talk about what we've got. What we're getting right in front of us is a clustered index scan. What that means is that this query was not able to identify an index that could help us. As a matter of fact, SQL Server itself is suggesting that we use an index that we're missing an index, and if we created this non-clustered index, things would be better. So let's go down and do what it says. Let's create that non-clustered index. Let's rerun exactly the same query. Let's take a look at our execution plan. Finally. There we go. Now what we've got is a nice clean index seek. So we're now getting the information, everyone can see that I hope, we're getting the information we want out of that index. But what we're also getting is a key lookup. Now this is a lookup operation. There's two kinds of lookup operations. There's a key lookup operation, and then there is a row ID lookup operation. A key lookup operation is against a clustered index, and a row ID lookup is against a heap, a table without a clustered index. Both of these are not necessarily evil. However, they are both potentially a problem. It's called a bookmark lookup back in the old days, or just a lookup operation now. What happens is you get more reads. Now you'll notice the estimated cost, and those are estimates. Also note the other word you could use is guess. Those are estimated costs on those operations. In this case, they're fairly accurate. You'll notice the index seek is 1%. The clustered index lookup is 98% of the cost of this query. What's going on is you're getting generally, and I always get this number wrong, so if I'm wrong and someone corrects me, that's fine. You get 3 lookups for the key lookup for every single lookup on the index seek. Now, for a really simple query like this that's returning how many rows? 2. No big deal. But for a system that's got, returning 100, 1,000, 5,000 rows and has a key lookup, suddenly this is an extremely expensive operation and something you need to eliminate from your process. So how do you go about eliminating it? That's the question, right? Well, let's drop our index and let's recreate it. And what we're going to do is reference the same key, which is the product ID, and then we're going to use the include statement introduced in 2005 to add the other 2 columns. And so now, taking a look at the same execution plan, same query, same data, the execution plan is completely different. What we've got is the single clustered index seek. Let's get the tooltip up here. Come on. There we go. We've got a single clustered index seek, and if you look at it, it's the seek predicate is going right against the product ID, and in this case it did a convert. It did a parameterization because it's such a simple query. It did simple parameterization, which is why you're seeing @1 instead of a value. But the seek predicate is exactly what we wanted. The output list is product ID and unit price, and the object reference was the index that we created. The reason this occurs in this manner is because what we have now is a covering index. A covering index is an index that satisfies all the needs of the query, either the where clause or the select list, both. But this one's very easy to identify. Key lookup operator or row ID lookup operator, those are your bad actors. Those are the things to look for. And again, I want to emphasize, it's not necessarily a problem. On a query this size, it's not that big a deal. Matter of fact, let me show you one thing. If we rerun the query without the index, we're going to get the scan. Hang on, let's get the key lookup operation back. If we rerun the query with just the key lookup operation, this query runs in 70 milliseconds, right? Now let's drop and recreate. Run our query again. Now the execution time says 0 milliseconds. That's not true. But what we saved here was 70 milliseconds. Honestly, on most systems, on most days, is that going to be a big win? No. However, let's take that exact same query and say that it gets called 1,000 times a second, or 1,000 times a minute even. Now, is saving that 70 milliseconds worth doing? Oh yeah. And then obviously as that number increases, it's going to be even more rewarding as you fix it. So we've already seen how the missing index works. Let's take a look at this query. It's very simple. It's going pulling 3 columns from the production order work order table, and it's doing a between statement, returning 100 rows, 200 rows, and we've got a query. It's doing a clustered index scan. Scans are not necessarily bad, but scans are frequently an indicator of a missing index, depending on the number of rows involved. In this case, we're going to take a look at the operation, and we can see that the estimated number of rows and the actual number of rows are accurate, which means the statistics are up to date, but it's 72,591 rows that are being scanned. That's a problem. If it was, if the number was 6, I wouldn't care so much, but this is big, so it would be a bad thing. But if you look right up here, SQL Server has suggested you've got a missing index. Not only is it suggesting a missing index, it's giving you a key value, order quantity. It's also suggesting the include. And yeah, I didn't let you see that before, but the other one suggested the include statement too. What we can do is, in SQL Server 2008, is right-click on this and say, give me the missing index details. It will pop over, show you a query. Now, it's commented out. You can't run it by accident, but it shows you a query that will use the right database and create the correct index, so you could build this into your system. Let's go ahead and run it. Close this out. Let's see what happened. Now we rerun it, and the execution plan's got a nice clean index seek. Now notice the name of the operator. All I did was take what was there, run it as is, and the name was name of missing index sysname. You're not going to want to leave that like that. You're going to want to edit that information, which is why it's really good that it comes commented out. It's very much a reminder for you to, 1, validate the missing index information is accurate, and 2, that it's going to do what you want. And you can see that basically the 2 seek predicates, again, simple parameterization occurred. You can tell that right down inside where the, if I move my mouse, you won't be able to see, but where it says convert implicit down near the bottom of that tooltip, and it says int at 1, and then right at the very bottom, again, convert implicit int at 2. That's simple parameterization occurring. Once again, nice simple stuff you can pull right out of an execution plan. Let's get rid of, well, we'll leave that index in place because we're not using it again today. Now then, we're getting into a real query. Selecting a couple of fields from the person table, selecting some fields from the address table. We're joining address to business entity address to person. We're going to do where Berlin is the city and where the postal code is a particular value. This returns 43 rows. Execution time is 671 milliseconds. And we've got a missing index on this. And it's suggesting we need an index on address on city. Now if we look at, let's just scroll up here. If we look at the execution plan, you see right at the beginning, it's got an index that it's using. It's using the index postal code, but it's doing a scan against that, which is very costly. Again, that's a guess. That's an estimate. Those costs are all guesses based on statistics. Never, ever, ever forget that that's what those costs are. Those costs are not real measures. Even though what I'm showing you is an actual execution plan and includes actual number of rows, it is a guess. Now notice in this case, this guess, index scan, assumed 1 row, but it actually returned 46. So there's some indication that you may have a problem on the guess. So let's follow the indications it said. Create this index. Rerun the exact same query again. Take a look at our execution plan. We got nothing. Now we're getting the same index scan. It didn't improve, although SQL Server now says, yeah, great. Your index fixed everything. It's so much better than it used to be. Well, yeah, I mean it is. It went from 700 milliseconds to 160, but you know what? I'll bet we can do it one better. Let's drop that index. Let's try an index that includes city and postal code. Now we'll rerun, same query again, same parameters, because we don't want it to change because, well, we'll get into that in a little bit. Now, oh crud, now we've introduced a key lookup. However, notice we've got a clustered index seek, an index seek, and a nice clean index seek. Well, we're getting closer, but the clustered index lookup, if we go and look at the tooltip on it, come on. I hate how tooltips don't always pop up, don't you? There we go. The output list on this is a single column address line. If that output list was 50 columns, I probably wouldn't do what I'm about to do. But I'm going to drop my index and then recreate it and do an include again. And now when I rerun my query, execution time is, it's up a little bit, but what I'm getting is, and difference between 180 milliseconds and 170 milliseconds, that 10 milliseconds, that's almost within the realm of the collection error. But now I'm getting an index seek. The key point, you can continue to try to clean queries as you go. Let's move on. And yeah, let's clean up behind ourselves a little bit. All right, now I've mentioned multiple times, statistics are the key to indexes. The optimizer, the query optimizer, can't know all of your data. It can't look at all of your data every time. So what it does is it creates these things called statistics. Statistics are simply a representation of your data, and it uses that to make guesses as to how that data is going to be accessed. Unfortunately, those guesses can be wrong. What I'm going to do is I'm going to create a new table. I'm going to select into this new table new orders. I'm going to create an index on it. There we go. I'm going to turn off auto update statistics. Now, set statistics XML on is a way to get an execution plan. So what I'm going to do is I'm going to run the simple query, order quantity, new orders where the product ID is equal to 897. I'm going to have the set statistics on, set statistics off in order to get the execution plan for this query. This is a good way to do it if you want to execute multiple statements but only capture certain execution plans. So now I'm going to begin Tran. I'm going to update my new orders table. I'm going to set the product ID equal to 897 where it's between 600 and 900. Now note, the data is going to change, but the statistics, because I've turned off auto update, will not get updated. Oh, well, they would have. I'm supposed to have that commented out. There we go. Now I'm going to set statistics XML on again, capture the query, and see what it looks like. All right, here we go. Now we've got the first query. It did a nice clean index seek. And we've got the second query, and it did exactly the same execution plan. So hurrah, it's all good, right? Well, yes and no. Notice actual number of rows 2, estimated number of rows 75. Now that's a pretty wide disparity, but it's not unheard of. It could be an indication of a statistics problem, but in this case it's simply the data distribution is such that this particular value was not accurately represented within the statistics, and so you get a slight disparity, 2 to 75. But it makes sense that what the query did was a nice clean index seek followed by a nested loop join with 2 rows. A nested loop join, of course, is scanning between each row of the index seek above down to the row ID. Now here, by the way, here is your row ID lookup table, down to that below. And again, it's 2 rows, against, one row each time, and the nested loop join, and out it goes. As far as execution plans goes, this makes sense. Here's the identical execution plan, but let's take a look at the data being moved. The estimated number of rows is 75. The actual number of rows is 87,123. Now that disparity is huge, and that is a problem, because what did we say a nested loop join does? For each row in the outer or top, it scans the bottom, inner, and bottom or inner input and outputs matching rows. 87,000 individual queries against this row ID lookup to bring back 87,000 little rows so they could output 87,000 rows at the end. This is an indication of a problem with statistics. This is a bad execution plan caused by statistics. So now what if we take exactly the same thing? What we're going to do is drop the table. I'm going to recreate it right from scratch, so we're doing exactly the same thing all the way. Statistics are still off on the database. Oops, actually I want them, my bad, nuts. I wanted them back on. Here I have the scripts down there. Grant, run the scripts that you created, you idiot. There we go. Right. Same trick, except this time I'm going to leave statistics. I'm going to update the statistics between the runs, okay? Just so we can see it. Now it's executing. It's going to take a little while because it is returning 87,000 rows. Notice, now with statistics updated, this thing recognizes, holy crud, I don't have what I need to actually run this query. These statistics are different than what was there before, and so I'm going to create a new execution plan because the statistics were updated, and the new execution plan is recognizing the fact that, well, with 87,000 rows, if I read 87,000 rows once and then 87,000 rows twice, that's a problem. Why don't I just scan the table and pull out 87,000 rows? And you'll see that the estimate and the actual are much closer now. You've got 87,000 versus 86,000. So now we've got something in line with what we should actually see. Let me turn statistics back on, get rid of the old table, and hopefully everybody got an idea on that. How are we doing on time? Good. All right, let's talk about ad hoc SQL. Now, usually when I'm presenting in front of people, I like to ask this question. I'll ask it now, and I realize no one can raise their hand, but raise your hands. No one in this room, right? No one in this room, no one watching at home or at work has to worry about ad hoc reporting, right? Everybody has all of their queries are run through stored procedures or through parameterized queries. Nobody ever sees anything like this query in front of us right now, right? Wrong. We all have to deal with this thing all day, every day. So here's a query. It's running select star from these tables. It's joining them together, and it's where the name is bikes, and it's the other name is touring bikes. So it runs the query. We get back an execution plan. It's an okay execution plan. It does have a key lookup. Maybe it's something we want to look at fixing. It also has a clustered index scan. Again, maybe that's something we want to look at fixing, especially because, you know, that nested loop join, it's scanning 500 rows for every row up here in the nested loop. Now, of course, in this case, it's bringing back one, but even that, it's still scanning 500. That could be a place we want to fix. All right, that's interesting. Let's take a look at this next query. Now, in this case, it's almost exactly the identical query, right? So you would expect to see probably an identical execution plan. And in this case, we do. So that's all great news. But the question is, if you've got all these kinds of queries coming into your system, how do you know which one, you know, how do you know which queries are common, which queries have a common problem? I mean, there's an index scan here. there's a key lookup value here. Maybe we need to look up, maybe we need to fix both these queries. How could you know that these things are nearly the same? Well, I'm going to show you. This is not used enough. Not enough people use it. I even forget about using the stupid thing occasionally. We all get concentrated out here on the out on the tree of the execution plan, and we're concentrated looking. Oh, look, key lookup. Oh, cluster index scan. There's a little operator up here right at the beginning called the select. Now, if you look at the tooltip, you look at it and you go, cache plan size, degree of parallelism, cost, and the query. Yeah, okay. Thanks, Grant. Very useful stuff. Talk to you later. Going home. Well, what if we look at the properties? Let's scan this out, lock it in. Now this is the properties for this select statement. Yeah, cache plan size. Compile CPU, compile memory, compile time. Yes, that's literally telling you how long that query took to compile. Now we're talking useful information. Optimization level. Haha. Now we're talking extremely useful information. Was this query optimized? Usually what you'll see here is one of three values: full, trivial. Full optimization means it ran through the optimization process. Trivial means it didn't even bother to run through the optimization process because the plan was so simple that there was only one single way SQL Server could ever execute it, so it didn't go through an optimization process. The other thing that you could see here, we don't in this case, but you could see is timeout. Timeout is a problem. Now, if you have a timeout, the thing you want to do is go down here and look for the reason for early termination. Now in this case, good enough plan found. It found a nice plan, it finished the optimization, it was done. But you could see other problems down here. But where I want to focus for the moment is here. Query hash and query plan hash. Now these were created, these came out in 2005. A lot of people don't use them, but if you've got a lot of ad hoc queries, if you're dealing with a CRM system, for example, or you're just talking about your basic reporting system and you've got lots and lots of ad hoc, and you want to identify common patterns, either common patterns in the query or common patterns in the plan, query plan, you come here and get these values. Yeah, reading them from the query plan like that can be a pain in the bottom, because what you have to do is go in, look at the execution plan and say, okay, well this one is, come on, this one is, let's see, the query hash is 0x08882397F. Okay, cool. Let's go down here and look at this one. Different query, slightly different thing, and the query hash is, oh, completely different, 2397F. Oh, wait, it's exactly the same. Now we know that this query and that query are similar. They may not be identical, but they're very similar. Also, you look at the query plan hash, you can see that that's also similar. So what does this allow you to do? This allows you to identify common queries or common query plans that are running in your system. What's the use there? Well, if you've got a common query that has a problem and you've got to fix it, you can identify it through here and fix it. Or if you've got a common query plan in your system, it's being used by lots of different queries, and you've got something to fix, you can identify which queries are using it. How do you do that? Well, that's when you get into DMVs, or DMOs, sorry, Dynamic Management Objects. We used to call them DMVs, Dynamic Management Views, but now they're called Dynamic Management Objects, and I always cross over. What I'm going to look at is sysdm exec query stats, and I'm going to cross-apply it to sysdm exec SQL text, and I'm going to get the SQL text where it's like select star, which I should only see these two queries that I ran 2 times. First off, I'm getting the execution count, the query hash, the query plan hash, and the text so we can see it. So let's just run this. So now you can see, yeah, I have run these multiple times. But now you can see that, oh, and by the way, the reason you see 2 of one and then each one is individually, because I ran them in such a way that the spaces, carriage returns were included, that made them different queries as far as the, optimizer is concerned. But you can see that the query hash is the same, the plan hash is the same, and now we can identify common queries and reuse fixes across these common queries. So now let's run this query. Oops, let's run it like this. And notice this one's a little bit different than the others. It's not simply bike and road bike. It's actually returning some different stuff. Instead of a select star, it's a select product ID. Now we see, while we have a very, very, very similar query, the query hash is different, the plan hash is different, and so this wouldn't necessarily fall into the same thing because, quite frankly, let's run it again. Query plan is different. It's doing different stuff. It's put together slightly differently. It's similar, but it's not the same. So these DMVs are really going to enable you to look into ad hoc systems. Let's take a look at this. We run this query. Brings back a single row. We've got a nice clean, what do we got here? One key lookup operation. Common problem, right? Index seek, clustered index seek, nested loop joins. It's all returning one row off an estimated 3. All right, let's go down to this next query. Same thing, product ID is equal to 712. Totally different execution plan. Same queries, completely different execution plan. So let's go back to our DMV. We see that the query hash in this case is identical, but the plan hashes are different. So if there was something about this query we wanted to fix, we could track down that these guys were similar. But because of the vast difference in the statistics between those two values, 461 and 712, we get completely different query plans for identical queries, effectively identical queries. So that's something to keep in mind, but it's definitely going to be a useful tool for you to identify common queries. Also, if you've got common queries with radically different execution plans, that is frequently an indication of parameter sniffing, which is our very next topic. Parameter sniffing is not a bad thing. I've got time. Good. We're hitting the ones I want to hit. We're doing great. Parameter sniffing is not a bad thing necessarily. Matter of fact, most of the time, parameter sniffing is your friend. Parameter sniffing is very valuable. What it is if you've got a stored procedure, and it passes a parameter. In our case, we've got this really simple one, address city. We're passing in the city value. Let's create it. And you run this query. What happens is SQL Server can look at the value being passed into the parameter, then take a look at the statistics in the table, compare the value to the statistics, and make a determination for the execution plan based on that value, based on that specific value, not based on a sampled value or a guess on the statistics. So if we run these two examples of this stored procedure, and hopefully I've cleaned up everything, we get two identical execution plans. It's missing an index. Don't worry about that. The key is that what we've got is two identical indexes. Now notice, clustered index scan, merge join. What's a merge join? Possible indication of missing indexes. And SQL Server even thinks there's missing indexes here. But that's not the key. The key is, let's get the plan handle for this query. It's right here. Now, let's remove this plan from cache. Okay. Now notice we ran it London, then Mentor. Now we're going to run it Mentor, then London. So first it was the 435 rows, then the 1. Now it's 1, then 435. Notice these execution plans look nothing like the previous execution plans. Why is this? Parameter sniffing. SQL Server's looking at the parameter values. It's identifying completely different sets of data. In the previous case, there was, it was returning a whole bunch of rows, so it created an execution plan optimal for returning lots of rows. In this case, it's found, well, you've got one row, so it created an execution plan optimal for returning one row. But the one row is not necessarily going to be optimal for returning lots of rows, because again, we're looking at an index scan, 400 rows with an estimated value of 1, by the way, and then 400 rows going through a loop join, so that means 400 rows scanned 400 times against this other thing to return the data. That's a lot of work, whereas the other plan probably was better for more rows. Now, why does this happen? This happens because data can get skewed. You'll notice that the data inside the system between these two values, and I'm very, very specifically picking these, is different. And you can get that in your systems. Now, most of the time, most of your data is going to be distributed in a very common fashion, but you can get skewed data. So the question is, if you've got skewed data, what do you do to fix it? You can't fix the data, so you've got to start working on fixing the queries. Now, one way to do it is to alter the procedure, and instead of simply passing in @city, I'm going to use a local variable. So now if I run this and execute my two queries, again, London first, then Mentor, if you notice, this looks more like the Mentor execution plan. Now, why is that? Because instead of parameter sniffing in this case, it's now using a local variable. A local variable is going to tell the optimizer, I don't know what local variables have. It can't sniff local variables. It's going to do a sample of the statistics, and based on the sample, create an execution plan. Well, the sample of our statistics is more like Mentor than it is London. Whereas if we run London through parameter sniffing, it's going to identify, well, London is skewed, but I don't know that. I'm looking at the statistics for London and creating a plan accordingly. So you run into issues. Now, that's one way to do it. But what if you don't want to introduce extra variables inside your system? Well, another option you can do is to optimize for. Now, in this case, what we're going to do is say we're going to optimize for the skewed case. And so now if we execute Mentor, we're going to see the London plan. So it's doing the extra sort operation to bring back the merge value. And by the way, anytime you see extra operations, that's usually an indication of a problem. That's another way to fix it. But again, that's looking at a specific piece of data and telling it, optimize for this piece of data. Your data changes. It could become that, if you want to optimize for London, values could change such that London is no longer the skewed data. Other values may become the skewed data, and so you're not going to be able to get that. Also, you generally don't want to have to try to track which piece of data is best in your system. So you've got another option where you can say, optimize for unknown. Now, that's effectively the same thing, you'll see here in a second, as writing a query with a local variable so that it can't do parameter sniffing. It does a sample against sample the statistics quickly. It does a sample against the statistics and returns the value back such that the execution plan is the Mentor execution plan. All right, how much time we got? 4 minutes. Okay, I'm going to try to get through this. Multi-statement user value defined functions. Okay, these things are heinous. I will tell you that there are uses for merges, there are uses for scans, there are uses for key lookups. None of these are necessarily a bad thing. Missing indexes is not necessarily a bad thing. UDFs are heinous. These things are evil and bad, okay? Don't use them. Now, that said, there are cases where you can use them as long as you're looking at very, very small data sets. Why? Well, very simply, they have no statistics. Having no statistics, SQL Server has to make a wild guess. So what we've got here is a function that creates a table, and it inserts values into that table from a select statement, and joins, by the way. And then we have another one, and it creates another table, inserts into that. And then we have another one that combines these two by selecting against each one of them and passing in values and returning back. And we probably get an error. Hang on. My bad. I always forget this. 1 second. My bad, my bad. Here we go. Right, good. Already created everything. Excellent. So now what I'm going to do is I'm going to run my select statement. So I'm going to select against my combined sales info UDF. Kick back, relax. Hopefully it'll be done before our 3 minutes are up, so we have a little bit of time for questions. There we go. It took 4 seconds, 4 seconds to return a measly 148 rows. But let's take a look at the execution plan. Okay, Grant, you're an idiot. What are you complaining about? That's a nice, clean execution plan. It's a table-valued function and a table scan, and you already said table scans weren't a problem. And so it'll join back and bring some stuff back. Yeah, okay, table-valued function. Estimated cost, 0. Well, that's cool. The estimated cost in the table function is 0. It's free, right? No, that's a lie. There are no statistics for the optimizer to use. So if the optimizer has no statistics, what does it do? It takes a guess. It does a guess, and, well, I don't have any statistics on this, so I figure probably one row. So it estimates 1 row. But if the actual values are more, and in this case they're 148, the plan is going to be different. So what do? Well, instead of all that mess, instead of UDFs calling UDFs calling UDFs, what if we just ran a query? Same 148 rows, actual execution time is 197 milliseconds, and we get a plan. Oh, and look, this plan has problems. Could you see these index scans and clustered index scans inside of the UDFs? No, you could not. All of that stuff is masked. It is a bad programming practice. Multi-statement UDFs cause so many issues, and they are very, very difficult to diagnose because it's all hidden away, and there are no statistics, so you have no clue what's going on. So this is really, really, really something to avoid. Let's see if we can squeeze in anything else here real quick. Query hints, no, that's just going to take too long. Let's talk about sargeability. This query returns an index scan. Well, why? If we go and look at the table, there's actually an index for sales order, for sales number. We should be able to get an index out of this. The problem that we're getting is that we are performing a function on this column. If instead we change the query, and notice I said a function on the column, not that we're performing a function on the left-hand side of the equal sign. Don't listen to that. You can perform the function on the left side, right side, doesn't matter. The fact is that it's a function on the column. That's the problem. If we run the same thing as a like statement, we get a nice clean clustered index seek. Just run it back again so you can see. Index scan, index seek. Why? Because like with a percent sign on the right, not on the left. If there's a percent sign here, what I'm telling you is different. With a percent sign on the right is a sargeable operation. That means it is search argument able. Search argument able means that you can get a good search argument. You can go against an index. Otherwise, it must do scans. Up here, this is completely indeterminate. It is non-sargeable. Therefore, it has to do a scan. Let's take a look at another example. We're going to do sales order ID in 3 values. Take a look at the execution plan. We get a clustered index seek. Not bad. That's not what I expected, I don't think. But what if we do between? Huh. I must have a index left in there. Another clustered index seek. Okay. Demo bug got me again. All right. With that, we're going to stop because we've got 9 minutes left and we want to open it up for questions.
Yep, that's good, Grant. In fact, the nice thing about testing this out, are you going to be at SQL Pass? Is that, are you going to be speaking there?
Yes.
Okay.
Yeah, I'm actually going to be presenting this session extended at SQL Pass.
Oh,
I won't skip
fantastic.
stuff.
Well, thank you for sharing and testing on the free training here. That's awesome. And hopefully a lot of you are going to pass this year. I hear it's going to be a great event. But I know we only have a little bit of time, so I'll go ahead and just start asking some questions for you, if you don't mind.
Sure.
Let's see. This one goes out to Christian. And he wants to know, what is the effect or overhead of adding included columns?
Well, first, storage. You're going to add, at the leaf level, it's going to be adding those columns. It won't affect the index tree, the B tree itself, because the key values are the only thing that are stored there. But it will add some storage at the leaf level. The other thing it's going to add is updates, inserts, deletes will take longer. So, judicious use. Include 1, 2, 3 columns? Sure. Include 50, 60, 100? No. It's just kind of, it's like anything else. Doctor, it hurts when I do this. Stop doing that.
All right, awesome. Well, I'll put this off to Kevin now. Kevin wants to know, how do you deal with lookups in SQL 2000 if you can't use include for indexes?
Okay. You have to change the key. Very simply, instead of let's go all the way back up to the top here. If instead of simply product ID, you would have to make a key on an index that included product ID, quantity, and unit price. That would be the only way to do it. It's 2000. 2000 frankly is limited. In quite a few troubleshooting options, it's limited. You can't do optimize for in 2000 either for parameter sniffing.
What's the status on on support with 2002? I thought it was ending. It's in like phase out support.
It's in extended support now. Yeah. The extended support ends in June 2013, I think is the date.
Oh,
I work at a company where I would say over half our production systems are still on 2000. So
wow.
It's a common problem. It's not one I enjoy. I feel like I've gone back to the Stone Ages every time I have to deal with a SQL 2000 database.
Oh, there you go. If you're a Microsoft rep for FM Global, you're going to be calling Grant straight away. There you go. All right, this one goes out to Bradley.
Trust me, they already bug us.
They already bug you. All right, what percentage of the time is the missing index suggestion accurate in R2? Does that make sense? Here.
Yeah, no, it is. That does make sense. Unfortunately, I don't have a good answer. It depends. I have seen missing index information be very, very accurate a lot of the time. I've also seen it be very inaccurate. I've seen it in cases where it will recommend putting an index on column A and B, and an index on column B and A, and an index on column A with an include of column B, and an index of column B with an include on column A. No. Don't create 4 different indexes just because this thing suggested it. It can be very problematic. So anytime it suggests something, yes, that's an indication, but it's not a command.
Okay. All right, and this one goes out to Andrew. Under the Messages tab, when you run an execution plan, how do you get it to display the number of milliseconds it took for the plan to complete?
For the plan to complete?
Hmm.
Well, in the properties of the plan, let's pull one up here. In the properties of the plan, on the select statement, you can see the compile time, but it's not going to show you the execution time on the plan. You need to capture the stats, stats IO and yeah.
And that would be the same in SQL.
Stats.
Okay.
So, that's the same in 2000, 2005, 2008. No differences there.
Okay. All right. All right, great. Hopefully that helps, yeah. Andrew. If not, Andrew, just go ahead and pose your question to us again. We'll see if we can get to it today. This one goes out to Priya. What is the difference between comma-separated index and include?
Comma Separated index?
And include. Is that
I have no idea what a
you need
comma-separated index is, unless she means a compound index, an index with multiple values in the key.
Not sure.
The difference is the key. Well, I'm going to make an assumption that I understand the question.
Okay.
The difference is that the key definition is different. An include only stores those extra values down at the leaf. It's not part of the key, so it's not part of the filtering aspect of the index. It is only part of the return values of the index. Hopefully that makes sense.
Yeah, hopefully it makes sense. If it doesn't, just go ahead and pose the question again, and we'll see if we can get to it. This goes out to Kumar, and this might take a little time, but it does look like a good question. Can you dig into a little bit about hash, merge, and loop joins? Explain them a little bit better.
Right. Whoa.
Is that a lot?
Okay.
Yeah, I thought it might be.
It's a lot.
Yeah.
In a nutshell, merge join basically takes it's roughly 1-to-1, and it requires the data to be ordered. Which is why, like in the one query we saw, it had an order by statement in addition to the other operators. It has to put all the data in order for a merge join. That can be okay if you're moving a lot of data and you've got good indexes in place so that the data can come back ordered from the index. SQL Server can take advantage of it. Moving a lot of data, that can be really great. A hash join creates a hash table. So it creates a work table in TempDB, and you can even see it when you go to the messages, stats.io and whatnot. You'll see here a work table has been created, and you'll see values associated with it. And what it does then is it does a probe against the hash table and matches values that way. Whereas a loop join, we described earlier, takes the values from the input row and matches them against the other values. For each one of those, it does a seek against the other. That's
Okay.
In a nutshell. That's it. I mean, there's a lot more specifics around that. I don't want to.
All right.
We could spend all day talking about.
Yeah. Some of these I could tell when I read it, but I knew you'd be able to breeze over it. Kumar, hopefully you're going to pass. If you are going to pass, you can, of course, go to Grant's session. And hopefully, Grant, if we can do this again, maybe we can dig into some of those topics a little bit further.
Sure. Yeah, I'd love to do it again.
Now, Melissa has been waiting patiently, and she wanted some further explanation on what you were doing when you were turning statistics off. So her question is, why were you turning statistics off and on back when you were doing that at about midway through?
Well, because I needed to cheat for my example. No, that's just it. Statistics are updated based on based on the amount of value inside the tables, and so you can get a skewed set of data without an update on statistics, and that can cause changes to your execution plans. And what I did was I forced a skew on my statistics by inserting the data first, turning off the statistics so they could not be updated, then manipulating the data, and then running queries against it. So it was a cheat for the example. In the real world, statistics would still update, but if you were talking about tables with a lot more values, millions of rows, which are fairly common these days, you can get a lot of data updated without statistics updating automatically, and you can see you won't see changes there. But it's just hard to set up for an example. So what I did was a cheat to set it up for the example. Another situation you can run into is, even though you're getting statistics updates, the normal updates on statistics are scanned. They're scanned. It's not a full scan. It's a sample scan. Yeah, that's what I'm trying to say. It's a sampled scan instead of a full scan, and so you can get skewed statistics because it's just sampling every so many rows instead of looking through all the values. And so all I was doing was cheating to skew the statistics so that I could get the bad execution plan I wanted.
Fantastic. And Melissa caught you red-handed, so nice job, Melissa.
Yeah.
This one's from Marco, more about your content that you're delivering today. Will the SQL example file be available for download either on SQL Server Central, or you can provide it to us at Pragmatic to download?
I can definitely give it to you in PragmaticWorks, absolutely. Okay. It's also available. It should be available here. http://scarydba.wordpress.com/resources.
All right, awesome.
scarydba.wordpress.
take that down, and if you miss it, we'll also, Grant, if it's okay with you, we like to provide the slides and whatever things you'd like the attendees to have. We'll put up for download on the calendar where you registered for the website as well. So you can go to Grant's site.
Yeah, I'll ship it right over.
Be all over the place. All right. So this one's Gail. Can the T-SQL scripts be published to the website? That's exactly what we just talked about. Sorry about that. Because you didn't put it. Okay, this one goes out to Andrea. How about adding with recompile to the stored proc to avoid parameter sniffing? Is that
yes, that is another option. But what that does is it adds a recompile to every single execution of that stored procedure. Again, if it's 100 milliseconds to recompile the stored procedure, it gets called once a day, once every 5 minutes. Who cares? But if it gets called fairly frequently, recompiles actually lock the procedure. So if, let's say you've got a procedure that gets called, 5 times a second, and it takes 300 milliseconds to compile. Every single time it gets called, it has to recompile. It's going to lock the other processes, so you're going to have one locking at least while it recompiles, and then the second one will execute. In the meantime, 2 more will now be blocked, and then it will complete its recompile, and so you've got a cascading problem. I've seen it happen. It's really scary bad. So yes, you can use it, but it could lead to other issues.
All right, great. All right, this one goes back to Christian again. You advise against using multi-statement UDFs. What about inline UDFs?
Inline UDFs are a completely different critter, and they're okay.
All right,
SQL Server
cool.
blows them out. They're the whole idea of talking about them like what do they call parameterized views? That's effectively what they are. And so they're okay. I mean, if you use a lot of them and nest them on top of each other, you could run into issues. But just using them, it's not a problem at all.
All right, hopefully that answers your question, Christian. Tim Cash, welcome back. This question goes out to Tim. Does SQL Server support function-based indexes?
Function-based indexes.
Need a little more clarification.
I'm going to say I'm stupid and I don't know. I'm thinking CLR has a way to do it, but I don't know. I'm gonna say I don't know.
And Tim, if you want to clarify a little bit further.
Good question. I don't know.
Okay. You stumped the chump. All right. This one goes out to Tish. If a stored procedure has table variables or temp tables, pound or pound, or dynamic SQL, are there any potential issues with getting an execution plan? And if so, is there a way around it? That a lot to digest?
No.
Okay.
If it's got temp tables, getting the estimated plan can sometimes be an issue. If it has temp tables, getting a plan prior to getting an estimated plan prior to 2008 can be an issue. It's not that big a deal in 2008, but getting an actual plan in any version of SQL Server is not a problem at all.
Okay, great. And we're a little bit over the hour here, so we'll get time for another question. Let's see here. One was a question about where you can get the ad hoc hash query from the demo. I think we've got that covered, right? Everything will be up on ScaryDBA, the website we have here. And let's see here. Now, execution times. Okay, this one goes out to Sandesh. How are you displaying the SQL Server execution times in the results pane?
That's stats. Hang on one second. I'll show you. You go in the query. You go to Query Options, Advanced, Set Stats Time and Set Stats I/O, or Set Stats Time, Set Stats I/O. Those will do the same thing.
Okay. Great.
And what that does is it makes the output look like this. It sets this is the time values, and then this is the I/O values. I turn it on. I actually have it real quick. I know we're over time, but I just want to show this.
That's okay. No, everybody's.
I'm bad this way. I just turn it on for everything. Where is it? No, not there. Yeah, I turn it on here in Options. It's Query Execution, SQL Server Advanced, and then every single query window I open has it, because I do a lot of query tuning. That's something that I do. So I just turn it on so I don't have to try to set stats time, set stats IO every time I want to use it. It's just always there.
All right, and it looks like, Tim Cash answered back with one of his questions here. It was FBI, the function-based index was the answer for that question that he had earlier. The index is created using the function clause. Then if the SQL matches the function, it uses the function-based index. So
okay.
Does that make sense? That was the one
Yes.
that stumped us. But Grant, this was awesome. Thank you for helping out today and offering the free training. We've got a lot of kudos here in the chat for you as well. And if you want to put your link back up there, how to get in touch with Grant, that's always a good thing for the audience.
Yeah, ScaryDBA is a good place to go. Or
yeah, and you also have a book that you've written as well that's up with, is it with Redgate Press or with Microsoft Press?
Yeah, one with Redgate Press, one with A Press.
A Press. All right, and you're
probably two with A Press, and a third one coming out with with Redgate Press. I've been writing. Anyway, yeah. The execution plan book is from Redgate Press.
Redgate Press, and that's only available through Redgate Press, right? I don't think they use Amazon or any of that sort of thing. So.
Nope, it's on Amazon.
Oh, it is on Amazon.
You
Fantastic.
can get it on Amazon.
All right,
Yep,
so you can just
absolutely.
search Grant Fritchey, and if you're interested and enjoyed what he had to talk about today, I'd encourage you to do that. And Grant, is there anything else you'd like to add?
No, I'm good.
You're good. All right. Well, thanks again for taking a portion of your lunch hour and working with us. And I'll see you at SQL Pass. By the way, we're going to be out there as well. Booth 510, Pragmatic Works and the gang will be out there. And we're going to go ahead and end the webinar. If there's any questions or anything after the webinar, you can reach us at the link that's on the screen now. Thank you, everyone, for attending.